Let us talk about decay constant of a radioactive element. We already discussed that at an instant, activity, which is measured in disintegration per second of a radioactive element, is given as this activity we write as mod of dN by dt, and its numerical value is lambda n, where lambda is the decay constant of the element and n are the number of undecayed nuclei or parent nuclei present at that instant. Now in this situation here we can rearrange this expression for lambda, where lambda will be mod of dN by dt divided by n. So it can be expressed as mod of dN by dt is activity of sample, or more precisely it is activity of all the nuclei in the sample divided by number of active nuclei in the sample. So you can simply see this activity of all the nuclei divided by number of active nuclei. So here the value of lambda can be written as activity per nuclei of a radioactive element. Here we can see we talk about lambda as activity per nuclei of radioactive element. It remains constant. So indirectly we can say lambda as a constant, and about it we can write it is a measure of stability of a radioactive element. Here we can write if an element has a high value of lambda, this implies it is a less stable element, and if a value of lambda is high, we can write it will have high activity. It is less stable, then only we can say its activity will be high, it will be speedily disintegrating. And for low value of lambda implies it is a more stable element and the activity would be low, because if element is relatively stable or more stable compared to an element which has high value of lambda, the activity of this radioactive element is relatively low. But in both cases we are talking about a radioactive element. More stable doesn't mean the element is perfectly stable, so it won't disintegrate. In that case the value of lambda will be 0.